So hello everybody, this is the time for ANSYS to speak. I'm Thierry le Sergent, product manager of SCADE Architect that support AADL, and I'm here with my colleague Guy Goretkin. I will handle the booth this afternoon. Before I speak about our tool, the SCADE solution for AADL, I will say a word about AADL itself, and my message is, it's not an island. That's an important message. So when you have to develop complex projects, in particular in aerospace and defense, most probably you will have to deal with AADL, the ARP guidelines, AADL for the system AADL for the virtual integration, FACE for the interoperable components, and at the end, certification of your embedded software. So to manage all that, most probably you will have many tools and big questions about the workflow on all that. So fortunately, there are links between all the standards, and could be brought directly by the standard. So for example, just before we spoke about the link between FACE and AADL, and I will show you a slide on that. Sometimes as a product, so for example, with SCADE, we have a strong link between FACE and the code generation that is certified, and many other things for the safety assurance, for example, on this kind of thing. To make the link in practice, there are several means. The first one that is supported by all tools is traceability. That's good. I mean, if you can do traceability, do it. It's supported by all tools, but it's mainly manual, but at least it allows for completion checks. A bit stronger way is what I say allocations. Make direct links between the objects coming from different models. It's a bit better or stronger because it can allows you to make easy checks or generate tables, reports, this kind of thing. But it requires to have all this model tied together, for example, in the same tool. And this is what we do with SCADE Architect. An even stronger point is to do synchronization of models. Synchronization means automated translation, automated transformation of subset of model, wherever it makes sense. Of course, it does not make any sense to try to translate the whole SysML stuff into AADL or vice versa. But a small subset of each may represent the same thing. So with an automated transformation, it allows you to make the different model consistent with each other automatically. What is nice with SCADE Architect is that it supports all these means. So depending on your workflow, on your process, on your project, you will have to balance the choice between all these means. So in practice, SCADE Architect is what you have in the green box. So we support the AADL modeler, FACE modeling, SysML, and even domain-specific language. We have a means to customize that yourself. I will not enter into all the details of the arrows there. If you have any questions, any need on any focus that is there, please come on our booth this afternoon and ask questions, either to Guy Goretkin or myself. And then forward of my slides, I will speak a bit more about the link between AADL and SCADE Suite for the qualified code generation. And I will also speak a bit more about AADL and FACE, the way we can make the link between this. Okay, so in short, for the SCADE solution for AADL, it's fully compatible with the latest version of AADL. The focus we add is on the ease of use. So what we mainly do is a modeler, a graphical modeler, easy to use. For the analysis itself, we rely on partners, whether it is OSAT or colleague from Adventium lab, or we can also use the tool from LEDs, for example. And that is possible because AADL is a standard. That's really the good point with the standard. Everywhere you will see that we can import and export textual AADL file, and the same for all the tools that will be presented today. That's really a real strength of the standard. In SCADE, one of the big benefits is to of the nice thing is to benefit from the great ecosystem that we have. link with SysML, link with SCADE Suite, link with Face, and so on and so forth. So just one screenshot of the tool. It looks like that. We can see a nice graphical view of AADL model with processes and devices here. And of course, any of the subjects can get properties coming from the annex, and this is made through this kind of dialog that you have at the bottom here. Okay, one technical slide, only one here, about the simplification that we make. AADL is a very powerful language, allowing you to define abstractions, component types, component implementation, and component instances. All that in SCADE Architect is done by component. You define just simple component that you can instantiate, and anytime you instantiate it, you replicate the component. So every single little element from the component is directly accessible, and you can put your properties, your timing properties directly on it, for example. So in practice, I will not enter into all the details, but you can see here the textual AADL on the left, on the way it is represented in SCADE Architect in the tree view of all the objects. Let's show that in two use cases. First one, it's an example that you will find in the book from Julien Delange. So inside the book, you have directly this model. I grab it and import it directly into SCADE Architect, so it was working already. Of course, I did not get the graphical diagram there. The graphical diagram, I had to make it myself, okay? But the language on all the model, the language on all the properties were imported automatically, of course. This is the view of one of the property. Press a button, it exports textual file, AADL file, the standard, import it into OSAT. You make your analysis into OSAT, and here for end-to-end analysis, for example, OSAT provides you directly an Excel table with all the timing information and telling you whether your assumption on the timing was good or was wrong. Another tighter integration has been made by Adventium Lab. So here the analyzer from Adventium is directly integrated into SCADE Architect, and you go into the tool menu, and you can invoke directly the analyzer from Adventium. It generates automatically an HTML report with the result from the analysis, and from there you have directly hyperlink to the graphical model. If you ask Adventium to generate the aand 653 scheduling, you get the textual information here that is generated in another window directly within the same environment. Again, that's one of the great benefits of having a standard. I mean, they use directly the tool as it is. Now let's move on to the code generation. We made what I call the synchronization, and I will show you more detail in the next slides, between SCADE Architect here for the support of AADL on SCADE Suite, and then from SCADE Suite you can generate code. So in practice, how does it work? You have the buttons to define your synchronization settings. Basically there you will select which subset of your AADL model you want to transform into a SCADE Suite operator. Then, when you are in SCADE Suite, that's here. One of the nice things is that this synchronization is bi-directional. So you can have started with the AADL model, select any of your subprogram or threads, translate into a SCADE Suite interface. You can also do the reverse. If you have already implemented SCADE Suite operator, you can translate it into a AADL subprogram or threads. Okay. When you're in SCADE Suite, of course, then you have to implement the real behavior using the SCADE Suite language, and then you can generate the code with the qualified code generator that we have, either for C language or the other language. Another synchronization working with the same technology is synchronization with Face. So in the new AADL Face Annex, we provide the mapping between AADL element and Face element. So we just use the SCADE Architect synchronizer to implement this mapping. And again, here I will not enter into each minor details of this transformation, but here you can really see the Face model on the left side and the AADL model on the right side, and this has been created automatically by model transformation. Of course, there are many more things in Face. I mean, all the conceptual level, the logical level, the views, all that must be created then in Face. But at least the minimal information on the UOPs, on the interface of the UOPs, can be translated from one side to the other. Again, it's bidirectional. If you have already Face component, you can integrate that as AADL component. If you have already an AADL model and you are happy with it, you can translate any of the straight groups here to a Face UOP. Okay, so in conclusion, SCADE solution for AADL, fully compatible with the latest version of the standard. Easy to use, it's made for that. And large ecosystem, allowing you to make the link with SysML, with Face, with SCADE Suite, everything that you need. One slide about the product packaging. Thanks, Jérôme, to have pushed for that slide. So the SCADE solution for AADL is provided directly with the SCADE installation. The latest version of SCADE is this release, 2019 R3. The next one will be released in January. And of course, it's a commercial tool. You have to buy licenses to use it. And the sales manager has his email address. Otherwise, you can ask Guillaume or myself at the booth. Thank you very much.
As usual, we have time for one quick question when we do a context switch with the next speaker. Ron? Mm-hmm. Thank you. Thank you. Whoa, they are shy. I do. Sorry? No, yours. Unless you want to speak on Ansi's slides. No, use that one.
Hi, my name is Ron Bagai. Good morning, everyone. My name is Ron Bagai. I'm the solution architect with Dassault Systems. I'm here with Dr. Garrett Thurston and Dr. Brian Chambers. Please stop by and see us after lunch. Let me summarize my talk. The case for the complexity of software in embedded software systems and the fact that the cost is increasing and we need to do reuse is already made. The case for ACVIP and AADL is already made. What I'm going to add to it is the fact that you also need to consider technical debt and contextual debt. This is systems versus enterprise. And to do that, you need a digital enterprise platform that has many dimensions. The first thing is to have a authoritative source of truth. It has to have a means for IP management, collaboration, and also include the AADL in there, in the platform. So that's where the journey I'm going to take you on. And the proof of concept that we did with AADL, with AADL Inspector and OSATE 2, which I'm going to share with you. So we talked about software-enabled capabilities and unstable trades and where we want to get to that the software that we're building is affordable. And this is the Airbus, that's the software growth in Airbus 350 over time. As you know, the DoD OSD and branches are moving to model-based acquisition. And part of the strategy and processes and technology, we see ACVIP and AADL, along with other frameworks. The concept of technical debt and contextual debt is basically technical debt talks about is a metaphor for lingering issues that you reason about, but you have to do something about it to decrease the debt over time. And when you get to contextual debt is about the enterprise and type of things like model-based systems engineering that includes product line engineering, product line management, etc. This is, again, talking about extending the concept from technical debt at the system level to the enterprise level. This is the type of things that you deal with on the system side. Again, ACVIP, AADL, which is the topic of this talk, and on the right-hand side, product line organization and enterprise architecture. So the question is, what is needed for containment of the accumulation of technical and contextual debt? And I argue that a digital enterprise infrastructure is needed to deal with many complex issues, including PLE, PLM, and also the type of things, family of systems, future of factory, and so on and so forth. This is the introduction to the Dassault Systems 3DX experience that has multiple dimensions to address, including the suppliers, the system of systems, and product applications and architecture. And as you see, I put a big red arrow that also should accommodate the ACVIP and embedded architecture that includes AADL. Again, you saw this chart before. The idea of earlier detection and continuous integration is the key. So in order to do reducing the accumulation of technical and contextual debt, 3DX experience supports authoritative source of single truth for ACVIP. As you see, it has different parts to it, one digital place for everyone to find information. You talk about one data network connecting all the domains, and also one managed digital place for everyone's work product, including dashboarding, agile work, and everything is included in this platform. Single shareable system model for ACVIP is included in the platform, including simulation. There is a safety for fault identification analysis. There is the interfaces, the components port for defining your architecture for systems. And also, again, test plans for day-to-day context use is accommodating that as well. And system modeling enterprise foundation. The AADL part also is included in the platform by defining the architecture for electrical and electronics architecture, which you can move from there to do all your performance analysis, your safety analysis, and schedulability analysis. So let me walk you through what I did with the platform to support AADL. So we started from Cameo Enterprise Architecture. That's the Dassault System acquired No Magic, if you had not heard that. And as part of that, the requirements, because you did the SysML already in Cameo, so you can see the requirements in the platform. Then you have your functions, which are transformed from SysML into functional items in the platform. From there, there's a safety app that you can do system-level safety based on functions. From those functions, you actually do your E topology and E components for software, and you do system mapping. From there, we have a translator that translates that architecture into XML format for AADL specification. And from there, I used AADL Inspector and OSATE 2 to perform temporal analysis. The feedback was very valuable back to our architecture. Then my second part was to do safety analysis. Again, we started from Cameo, did the requirements, the functions, safety analysis, EEW, architecture, XML format. We did temporal analysis, feedback. We added EMB2 annotation, and then we performed safety. But the biggest value here was the feedback to other safety that we did based on functions. This is an example of GPS system with 1 sensor and 2 sensor in OSATE 2 that I put in. Here's some screenshots of the functional architecture in electrical electronics app in 3DX platform. Here's a hardware architecture that you're defining the architecture in the platform, the system mapping. And here's the EEA App to AADL objects relationship that we have established as part of the translator. Here's the object relationships. Here's our translator that translated the architecture into AADL syntax. And here's what we used AADL Inspector to do the execution. Future work, what we are doing now is, I showed you this. What we are trying to do is not to do AADL annotation there. We're going to do it at the time that you are defining your components, your architecture, your buses, and everything else. We think it has a lot of value doing it there at that point as part of properties of the components. Key takeaways. I think we also need to address technical and contextual complexity. The application to address ACVIP is a containment of accumulation of program depth. I think it's important to do AADL in the same digital enterprise platform that you have everything else. And at the end, we believe that to do all this and meet the ACVIP goal, you need a digital enterprise platform that can accommodate all these dimensions of complexity. Question? Yes?
Product line engineering would seem to add to that complexity, contextual complexity. How do you deal with that? I just saw one little mention, but that's really important.
Yeah, so we are doing product line engineering at 2 levels. One is at the specification in the at no magic Cameo level. So that's the domain. And then the realization of that, which is the big E, product line management, is in the enterprise, which is in the 3DX experience.